So now that we've gone over the various types of routing protocols there are, both of them actually, we're going to start learning about EIGRP. And like always, we're going to start with a basic overview of how EIGRP works, then delve into the specifics of how it accomplishes its magic, and then put it in a lab. Everyone loves the lab. EIGRP stands for the Enhanced Interior Gateway Routing Protocol. EIGRP is a Cisco proprietary protocol, and it is a successor to IGRP, or the Interior Gateway Routing Protocol. Now, I will tell you this, if you have an all-Cisco network and you're only ever going to have all Cisco equipment, EIGRP is one of those things that pretty much just works. You set it up, you advertise the networks into EIGRP, and it just works. It's a lovely little magic. And of course, like with any routing protocol, you can get in there and tweak and tune all the various parameters and make it perform exactly like you want it to. But it's kind of like Spanning Tree. Out of the box, you turn it on and it just kind of works most of the time. And it's because of that ease of use and ease of configuration that I've decided to start with EIGRP instead of OSPF. If you read a lot of the Cisco courses, including some of the approved Cisco Press books, they'll go into OSPF and then talk about EIGRP. And I have done that in courses previous, and some of the feedback I've gotten has been, why didn't you teach us about EIGRP first? It's a good way to get our feet wet. And so, as a nod to all of those people, I'm going to start with EIGRP in this course. So anyway, Cisco refers to EIGRP as a hybrid routing protocol. They don't want to call it a distance vector routing protocol. They don't want it associated with RIP and all of those other distance vector routing protocols. But in reality, it is a distance vector routing protocol, but it's an advanced distance vector protocol. Like distance vector protocols, it does not maintain a full network map in each router. All it knows is the metric and the next router in line, which classifies it as a distance vector routing protocol. However, EIGRP does have some similarities with link state protocols, and that's why it's an advanced distance vector or a hybrid protocol, if you want to call it a hybrid protocol. First off, it uses hello packets to discover neighbor routers and maintain neighbor relationships. Unlike RIP, RIP just broadcasts everything, and everybody that hears the RIP advertisement will take those routes and import them into the routing table. EIGRP has the concept of neighbor relationships like OSPF, and you'll see that concept come up again when we discuss OSPF. EIGRP also uses an algorithm to determine the best loop-free path through the network. Again, unlike RIP or other distance vector protocols where they basically use hop count, EIGRP does use an algorithm to figure out which path has the least latency and the least delay and the most bandwidth available to it. Now, as we've mentioned, EIGRP does maintain these neighbor relationships, and EIGRP uses a basic sanity check of new potential neighbors. When an EIGRP router comes up on the network and starts multicasting its hello packets, the neighbor router says, oh, there's a new router there. Let me perform these basic checks to make sure that you're not going to corrupt my routing tables with some garbage routes from some place that I don't really even know about. And in short, those basic sanity checks are the MD5 authentication parameters must match. Now, you're not required to use MD5 authentication, but if you're not using authentication on one interface, then you can't be using MD5 authentication on any of the other interfaces. So they have to match either present or not present. Both routers must be in the same autonomous system, and the autonomous system is simply a number that you give the EIGRP system. And obviously you can have multiple autonomous systems in the same routing domain, but routers in different ASs cannot become neighbors. The address that the neighbor is known on must be in the same subnet as the interface that the hello packet is received on. Again, that seems kind of brain dead and kind of, duh, of course they have to be in the same subnet. But you'd be surprised sometimes that routers that are on different subnets start multicasting EIGRP packets and you start getting errors in your log saying, hey, they're in different subnets, I can't become a neighbor. And finally, the K-values must match. And we'll talk about K-values when we discuss EIGRP in depth, but just realize that if the K-values are different between two neighbors, they cannot form neighbor relationships, and you'll see why when we discuss what K-values are. So once an EIGRP neighbor has formed, the routers can then start exchanging routes. So what happens when we start exchanging routes? Well, a full route update is sent when the neighbor relationship is formed. Hey, here's my entire routing table. Here's everything you need to know about me. Partial route updates are sent thereafter when a link state change occurs, like link state routing protocols. However, unlike link state protocols, there's no periodic flooding of the topology information across all of the routers. Basically, if you miss a link state update from EIGRP, you better hope that you've got another path to that network because you're not going to get it again 30 minutes later. Most of the time, like with OSPF and other link state protocols, that's not a big deal, but it's important to remember that is one distinction of EIGRP, that you don't flood those topology packets ever again once you've come up and established a neighbor relationship. And that concludes our overview of EIGRP.